Okay, I am doing problem number 17, chapter 9. And the way the problem reads is, a computer company conducted a new and improved course designed to train its service representatives in learning to repair personal computers. There were 100 trainees who were split into two groups. One group took the customary course, the ordinary course. The other one took the new and improved course. At the end of the training, after 6 weeks, all 100 were given the same final exam. Now, below it's asking us to do a chi-squared test to test the null hypothesis that the two courses were the same, or actually we're testing that the new course was no better than the customary course in terms of teaching representatives to repair personal computers. All right, so the first thing you want to do, I always have to do, is I have to write my null hypothesis. All right, so in order to say that the second course was no better, basically means that the averages from the first sample were equal to the second sample. All right, your research hypothesis or your alternative hypothesis is going to be that they were not. That the old method was the same, average scores of the old method were the same as the first. If we find that to be the case, then we could say, okay, it's not customary. You might want to look at this data if you were thinking about investing money into this new and improved system or way of training. Or one way to do is to say that the people who did it the customary way actually scored better than the ones who did the new method. Or we could say, these are just other examples, because some people have asked, why do I always do this population not equal to? You could also do it this other way, saying that, okay, the new and improved course actually scores were actually lower than the, which is the same thing here. I wrote it the same way. So if I wrote n sub mu sub O is less than m sub 1, this would be that the new and improved people who took the new and improved class actually scored higher. And that's the same thing if we were to just rewrite this. If I have n sub O and I bring the minus sign over, minus n sub 1 is greater than 0. All right, same exact thing. But I just always do this one because it's just easier than writing the other things out. But if you wanted to prove the other things, you could do the same thing. All right, so what I'm given this table, and I know that this is my customary or traditional course, and this is the new and improved method. All right, so think about this class. This could be you just using your book. This could be the new and improved actually using videos, whatever. All right, I know that I had 50 in each sample, and then I know what their scores are. I know in the customary group, 15 people scored above average, 25 scored average, and 10 below average. And then in my new and improved group, I know that 19, 23, and 8. The very first thing that you want to figure out, remember everything's about tables and keeping it orderly, you want to know what your expected results are. To get expected results, you have to kind of look across the tabulation. So above average, if I know that 34 people scored above average, if I'm trying to prove that it doesn't make a difference which course they're in, those are going to set those equal to each other. So this 34 means that I would expect to find 17 people who scored above average in this group and 17 people who scored above average in the second group. All right, so here, 48 people scored average. If my null hypothesis were true, that the sample averages from the first group equal the sample averages from the second group, m sub 1, you would expect to find half of them scored customary, half of them scored new and improved, okay? So this one would be 24, and the same thing here. The 18, you would expect to find the same number in each group, all right? 9 and 9. In parentheses here, these are nothing more than my expected frequencies. All right, so I can now write them up here. So that's why I wrote upper left, upper right, middle left, lower left, lower right. All right, these are my scores: 15, 19, 25, 23, 10, 8. All right, I'm gonna write my expected results. So 15 in the upper left category, I would expect to find 17. And I always write it like this because I like to keep my 17s and 17 together. My upper right, I would expect to find 17. Just plugging in my numbers, 24, 24, and then 9 and 9. Now the next step is to actually take the difference between the two. So my observed frequency minus my expected frequency column is just going to yield me 15 minus 17 is minus 2, 19, 17 is 2, 1, negative 1, 1, and 1, negative 1. You're then going to square those. So I've got f of o minus f of e squared. Negative 2 squared, 4, 2, 4, 1, 1, 1, 1. This is nice. I like the math on this one. All right. Now my final column is just my observed frequencies minus my expected frequencies squared divided by my expected frequencies. All right. So 4 divided by 17. Let me just 4 divided by. All right, I'm going to round to the point. I got 0.2352. I'm just going to round it to 0.24. All right, 4 divided by 17, 0.24 again. 0.04 here, 0.04 here, 0.11, 0.11. All right, that doesn't always happen, but it did in this case. So my chi-squared is actually equal to 0.78. Now the next thing I need to figure out is the degrees of freedom. And the way to calculate degrees of freedom when you have more than 2 categories here, it's going to be, this is the formula. All right. So you need to know your rows and columns. So if you look in here, how many rows do I have? I have 3 rows, right? Above average, average, and below average. So my degrees of freedom is equal to 3 minus 1. And my columns, I have customary and new and improved, 2 minus 1. So my degrees of freedom is just simply going to be equal to 2. All right, we already calculated this in the last problem, but I'll go ahead and do it again. I'm going to use 2 degrees of freedom with an alpha equal to 0.05. And this can be expanded out into, if you think about it, if I had 6, just happens to be a 3 by 2, right? But if I had a 6 by 7 or a 7 by 8, whatever it is, you do the same thing here. All right, you go to the back of the book, and remember we're using table, I can't remember what the book calls it, table E here. You're going to go to your degrees of freedom, 5.991. All right, with a 0.05 alpha. So the way you draw this out. All right, now all of you've noticed by now that the starting point here is 0 because we're squaring everything. So when you get your critical value, it's equal to 5.99. All right, so this makes this area here the rejection region. So anything greater than 5.99 will be rejected. All right, and then you actually go back and you look for your 0.78, all right? Which is about here, 0.78, which is not in the rejection region. So we're going to retain the null. Retain the null. Remember, the null just simply said that they were all equal to each other. There is no difference in course outcomes. All right, retain the null or fail to reject. And if you go back to your null and you read it, it simply said that the average score of the first sample is equal to the average score of the second. So there is no significant difference in course outcomes. The book goes on here. Also, another thing I want to point out here, we did not have to use any sort of measurement because remember that we got the expected frequencies 17, 24, 9, 17, 24, 9. They're all greater than 5. So we did not have to do anything specific for these. If they had been less than, and actually, you know what, I'll make another video on that. We would have had to use a different formula.